Hi everyone. Continuing our educational series on bespoke precast concrete products, this presentation focuses on the impact of 3D printing in producing aesthetically refined architectural precast units. There is no question that technology is helping us simplify our challenges. In particular, architects are increasingly pushing the boundaries of what can be achieved with concrete, aiming to create more intricate and visually striking designs. We have already covered the QA process of staircases in previous sessions, so I'm not going to revisit it in details here. Instead, I'll briefly walk you through a recently cast unit from our facility. The standout feature of this piece is the arc at one of the landings, where the designer specified a smooth, rounded transition into the landing, something that required careful planning and execution.
Apart from the arc that you can see in detail A on the drawing, all the rest of the staircase is the staircase which is comparable to our previous products. The weight of this staircase is a bit lighter, and it's slightly lighter than the previous staircase that we discovered here. So it's 2026 kg. The width of this staircase in the widest side is 1342 millimeter. The length of this staircase is 2271 millimeter, and as I described, the weight of this staircase is 2026 staircase. So like the previous one, it has come three stages for QA checking. First was after the mold is prepared, the angles should be checked, the goings, the nose to nose dimensions should be checked, the waist of the mold should be checked, correct. Uh, Embedded items should be used. So we've got protruding rebars. We should be really careful about the length of it, the height of it, where it is exactly positioning, as it is needed to exactly seat on the landing that it was designed for, and all of these issues that should be checked. But apart from all of them, the arc which has been designed and shown on detail A on this DWG is should be casted properly and intricately.
For nearly 15 months now, our designers have been using 3D printing to produce architectural segments used during the mold preparation stage. One key challenge is that these printed elements must act as a reverse or negative of the final concrete shape. In simple terms, if the desired concrete outcome is 1-4, the 3D printed insert must be its inverse. If you look at the image on the left hand side of this slide, you can see a blue rectangle which is named as element 1 and a yellow circle which is named as element 2. So if you want the cutout of that rectangle 1, so what the designers should design in 3D printing is the arc which is which has come out of the circle 2 here. So this requires designers not only create the staircase itself, but also model the reverse geometry for accurate molding. Credit goes to our design team for mastering this process. In this slide, you can see how the 3D printed components is installed in the mold. A critical step is ensuring that the joint between the printed piece and the timber mold is properly filled, sanded, and leveled. The finish should be smooth to the touch with no visible imperfections that could affect the final appearance. When everything is designed, set up, and quality checked correctly, The result is another outstanding precast unit that meets both structural and aesthetic expectations. So, in the images, you can see the perfections which has come to the reality. Yeah, this is an AI generated vision of the future of precast staircases, maybe one day. While it may appear imaginative today, such innovations are likely to become reality in the coming years and in the years ahead. But one key challenge still remains in my head, and that's the integration of steel reinforcement within current 3D concrete printing process, particularly for structural applications like staircases. Maybe I'm going to deep dive into it and find out whether there are any solutions or not. But thank you very much for being with me and watching my videos and slides. Take care. Bye for now.